here's the list of changes, and now I'll go through like each change a bit more in detail. So first, a big change we did is using geometric expansion. Like normally, in older version of WindSim, we've had this arithmetic expansion. That means that the grid expands at a uniform rate. For example, if first cell is 10 meters, then the increase with 5 every cell. This goes from 10 to 15, 20, 25, 30. So with the same factor. But with the geometric grid expansion, then it expands geometric way. So if you add like 30%, so maybe then it's 10 plus 30% is 13. What is it? 17, 22, 29. So the cell size increases much faster. You can also see that on the two pictures I made. So on the left side, it's the typical one that we've used to have, the arithmetic one. On the right side is the geometric one. So what's very important is, of course, the swept area of the rotor. There you want to have lots of cells. And also the closer you get to the ground, also the roughness impacts the wind flow more. So also you would need a lot of cells close to the ground. And then above the turbine, it's less important, so you can expand faster. This is something we've had before. If you know how to edit this BWS file, you could do this manually for, probably from the beginning. I'm not sure, at least for a long time. But now at least we have some settings in WindSim 12 that you can set this better. And also, an advantage is that you actually use some less cells, so then you can calculate faster, or you can use the cells more for the XY direction. Yeah, the next thing also we changed is that you can actually set the first vertical cell height. You could also see that here. The default, we set it at 2 meters. Then we think that's a good default value to start with. Like I said before, it's important to have small enough and enough cells close to the ground. And this is what we've seen is a good default. But so that's a good balance between accuracy and computational efficiency. Of course, it's something you can test, see what works best for your project. It depends on, it can depend on a lot of things, but this is a good default. Right, trying to change the slide. It's not working on my. Okay, there. So we also have introduced the hyper solver. We've called it hyper solver, but it's not really hyper solver. It's the hyper library, and it includes the Boomer AMG preconditioner and solver, and it uses the algebraic multigrid algorithm. So multigrid is let me see. Yeah, so the multigrid solver, on my next slide, I will explain a little bit more. So the main benefits is that we can solve large projects faster. It's more, it works better for the CPU usage is better optimized. And also it enables future developments like semi-unstructured grids that we plan on implementing in the future. So what Hyper does is then, for the same project, it will calculate much faster, or on the average, much faster. So what is a multi-grid solver? So the big challenge we have in CFD is that we have a large number of equations, and they describe the fluid behavior at each cell in the grid, and we need millions of cells. So it's quite complicated. So the multi-grid solver, it starts small, so it solves the problem on the fine grid. In the beginning, it's not perfect, but it has a good starting point, and then it goes bigger, so it creates a coarser, simpler grid. So the problem is easier to solve on this coarser grid, and then it goes more detailed again, and then back and forth. So it's a bit similar as what we had before. With nesting, you could run a coarse grid first and then use nesting to have a more detailed grid. But with this multi-grid, it does it like automatically. So you should be able to solve it faster with less iterations. I also added a diffusive link, a boundary condition at the top. Yeah, so it sets a fixed pressure at the top and imposes a constant speed. And also you could have like a lower height on the model. Yeah, it works best for offshore models. Yeah, it's not tested very much. We haven't used it for many projects yet, but so probably you have to do some own validation and see if it works for your projects as well. Also, always we have had this convergency value. That was just a number. The default used to be 0.005, and many people always, yeah, what does the number mean? And yeah, how does it work? Well, what's the correct number you should use? So we changed it you can still have these values, but we also have made some drop down box. So one value we call exploratory. So that's just for rapid evaluation. It's lower accuracy. So yeah, that was also an issue we had before, that a lot of the settings we had in WindSim 11 were more like for a demo case. And if you want to run a really complex case with a lot of accuracy, you need to change the values. We've seen some people, they use the defaults too often. So we changed some of the defaults in WindSim 12, and also to make it more clear also with this one. If you run an accurate simulation, then it's better to use these types of convergence criteria. So it's a bit more, a bit more strict. Of course, it will have some longer simulation time, but you will get a much more accurate solution. So the results are more trustworthy and reliable. So we recommend, we have this at the default, and we recommend this for most scenarios. But if you want to do like screening or something, you could have the exploratory version. We still have the manual version, so you can change the settings to something else if you want. The reduced wind based horizontally is also a new option we have. It basically, the terrain and wind fields is the same as before, but after wind fields, for the post processing, you can choose to only post process the refinement area. So then you use a lot of less cells, so it will be fast to calculate. We've seen that this has had a big impact on a lot of the post-processing routines. So we have a couple of known bugs actually with some of the exports, but it's something we work on and try to improve. So yeah. So it's a setting inside of the wind fields. Yeah. For objects, we've included the power curve information about the IEC turbine class. So when you include it, you can do it either through the OWS import file or via the GUI. And then in the later modules in energy, these settings are used, and for example, we see if the class matches. I don't remember all these exact IEC criteria, but for example, for one class, it's one speed that it should handle, and then you can see based on our results if this turbine fits in this area or not. Wind resources. We've implemented a new export feature, so we can export wind resource map to the server format .grd. So then it will be easier to export to other tools or to other programs or your own tools. It's easier for you to script and do your own calculations. yeah, so you can find it either in the project or in this yeah, the project layout energy grid directory. We also have introduced the AEP and IEC report exports in the energy. So that are tab separated files that provide data on energy production and turbine class suitability. So that's also why we did this change in objects. So to be able to do this turbine class suitability that's connected to this. So in the AEP file, we provide an information on the annual energy production, and it includes data. Yeah, like in this picture is a small screenshot of how the file looks like. So average wind speeds, wave parameters, energy, waked energy, extreme wind, shear, and yeah, and other things. And for the IEC results file, that data contains data related to the turbine class. You see like the ISC, turbulent intensity reference, roller exponent. Yeah, and here also you see like, yeah, so the header and the file is not so easy to see, but you see some true and false in this column, and that is then connected if the turbine fits here or not, if it matches the IEC criteria or not. Also the matrix table export, there's also tab separated file that then you can see a separate sector-wise breakdown of the turbine energy production, including wake, turbulence, and speed frequencies. Yeah, so it's also information about ambient and effective turbulence. Yeah, and then you can use this to analyze curtailment, some other IEC checks, and many more things. So it's just these exports is just to make our data that we have in the WindSim more available for other systems and for your own scripts, so it's easier to post process. So also in energy, we made a change in the time series calculations. Like before in WindSim, we always use the wind rose representation, and then we can convert it, transfer it to other positions, and then we always had some inaccuracies due to interpolation of wind speed frequencies, especially if there was a large directional shift. It's not a huge impact, but in some cases it could reach several percent error or inaccuracy. So WindSim 11, we improved this a lot. So then we used the time series directly. But one issue was that if there were some data gaps, if we have some zero output, if there was some missing measurements, then we set this value to 0. And then of course that was not completely correct. So in WindSim 12, we fixed this and take away those data gaps. So the results then are much better. So you get higher AEP values. Meso microcoupling. So we improved the meso microcoupling console and GUI that we have had in WindSim 11 already. So in WindSim 12, we did many improvements. Including the biggest thing is the addition of the post-processing feature for the self-organizing maps, and also the wind resource and energy model also now can have this self-organizing map results by weighting the frequency-based sectors. Also, post-processing is still in beta, version, so not all the energy exports and IC calculations are available yet. But in this document, the getting started meso microscale coupling, we explain more. And so you has a session later today telling more about MMC. Maybe not exactly about this self-organizing map, but you'll hear more from him later. Also, we've introduced the WindSim virtual desktop. Like Ingvar said earlier today, we have some challenges that we only run the simulations in Accelerator. So you have to start on your desktop with WindSim 11 or 12, upload your project to Accelerator, run the simulation, and download again for the post-processing. Some people with slow internet connection or other issues, yeah, that can be yeah, can take some time, and also you still then need to have WindSim installed on your local machine, your local network. You still need help from your IT department. So also, if you want to skip that, you can use the virtual machine. So that's just a normal Windows machine in Azure. We have installed WindSim and WindSim Express on it, and it's much faster to work with Accelerator, because then you can do the pre-processing on this virtual machine, and if you upload, it's really fast because it's in the same network as Accelerator. So, and the same also with the post-processing. You can also do that on a virtual machine. So it's just looks like a normal machine. We provide you with an RDP file, remote desktop file. This is just to double click username, password, enter username, password, and you log in. It's just like a normal machine, or how you remotely connect to a server. Or yeah, that was actually it. Yeah.